All right, A and P2 students, we are going to continue our talk about the urinary system. The last video we talked about the reabsorption of substances that are completely reabsorbed, and we kind of focused on glucose and protein, and then we also talked about why glucosuria occurs in people with diabetes mellitus and what's causing that frequent urination and thirst. So the next thing we're going to continue on talking about are tubules and tubular secretion and tubular reabsorption. And we're going to talk about the substances that are regulated. They're not all completely reabsorbed, so their reabsorption kind of depends on what the body needs to keep the right amount in the blood. And so we're going to talk about ones that are regulated, and then we'll focus on sodium and water. So the substances which are regulation is reabsorption is regulated, definitely sodium and water, but you can also see this with potassium and bicarbonate, and also the calcium, which we talked about with the skeletal system. I know that was an A&P one, but we talked about that parathyroid hormone regulating calcium absorption and secretion. So actually it was absorption for that one. So but we're going to focus just on sodium and water. And we'll talk more about potassium and bicarbonate in another chapter, so we'll get more details about them. But for this chapter, we're just going to focus on sodium and water reabsorption. So let me go to our picture. We'll move along. Okay, so I think this is our sodium one. Yep. All right, so how they did this is they show the nephron here with little peritubular capillaries, and then they kind of enlarge it so we can look at what's going on at the cellular level. So for sodium reabsorption, in the proximal, and remember sodium's one of those substances of the plasma, so all of it's going to leave the blood during glomerular filtration and end up as tubular fluid, tubular fluid. So in that proximal convoluted tubule, a lot, more than 50% of the sodium is going to be reabsorbed. And this is how it is done. So here is our peritubular capillary, its wall. And then we have the interstitial fluid. And then we have, this is going to be one of the tubular cells that are in the proximal convoluted tubule. So with sodium, it's higher in the tubular fluid than it is inside these cells. And generally that's true. We have sodium potassium pumps working to pump sodium out and bring potassium in. So generally, potassium is always higher in the cell, sodium is always higher outside the cell. So we're usually going to have a lower sodium inside cells. So the higher amount of sodium in the blood, in the tubular fluid is going to use just a little transport protein in order to get into the tubular cell. And then the little sodium potassium pump is what's going to pump it into that interstitium. So remember, there's always like 3 sodium pumped out for every 2 potassium pumped in. And then once it gets in the interstitial fluid, then it'll find a little couple cells where it can squeeze through and get it back into our bloodstream. And this would be like our peritubular capillary that we're talking about. So most of our sodium, 65%, is going to be reabsorbed in that first tube of our nephron. And then as we look at the nephron loop, there's going to be some more reabsorption. 25% of the sodium is going to be reabsorbed in that area. And then when we get to the distal convoluted tubule and the collecting tubule, collecting duct, that is where we get regulation. So we only have about, varies, but 90% of reabsorption of the sodium here. So now, depending on what our sodium level is in our blood at this moment, will determine what kind of reabsorption we get of sodium along these last few tubes of our nephron. All right, and so how that is regulated is a hormone, and you've heard the name of this hormone before. So it's called aldosterone. So aldosterone is a hormone that's made by the adrenal glands. And so whenever aldosterone is secreted, it will have, and we're going to look at this big picture down here, but it will have its effect on the distal convoluted tubule, collecting duct, and collecting tubule and collecting duct. So this is what it does. It's a hormone that will have an influence on these tubular cells that are, they call them principal cells, but we'll just call tubular cells in the distal convoluted tubule. It's going to cause this cell to increase the production of sodium channels. Oh, that's not sodium one. Sodium channels. And then also increase the production of sodium potassium pumps. So you can imagine if you have more sodium channels, more sodium potassium pumps, you're going to get more sodium that can pass through these cells, tubular cells, and then get into the peritubular capillary. So that's what happens. So aldosterone can regulate sodium by causing more sodium reabsorption. So we'll get more sodium reabsorption into our peritubular capillaries if we need to. So again, it depends on our state at that moment as far as how much sodium we have in our bloodstream. All right, now there is another regulating hormone that will regulate our sodium, and that is called, and you've heard it before, it's called the atrial natriuretic peptide, the ANP hormone. They don't show it on this picture, but essentially what it is going to do, it will actually work back here on the proximal convoluted tubules. It's an inhibitor. So what the ANP hormone wants to do is to inhibit sodium reabsorption, so lessen sodium reabsorption. So it can work at the proximal convoluted tubules. Not exactly sure how it does it, but it kind of blocks the sodium being reabsorbed here. And then it also will block aldosterone, not allow it to bind and not allow it to increase sodium channels. So that will prevent the sodium reabsorption. So that hormone, depending on, again, the state that the body's in, if it needs to be done, then the ANP hormone will be released from our atrium, right atrium, and then it'll cause a decrease in sodium reabsorption. So we'll have less sodium reabsorption going on at our nephrons. All right, so that's sodium reabsorption. So the next substance we'll talk about is our water, the reabsorption of water. And there is a picture. Here we go. So we have again that little nephron here. And then we kind of zoomed in so we can see what's going on. So realize they don't show a picture of what's going on at the proximal convoluted tubule for water, but definitely a lot of the water, about the same amount of sodium, 65% of the water is going to be reabsorbed along the proximal convoluted tubule. And essentially the reason for that is sodium's being reabsorbed there and moving into those peritubular capillaries. So water follows sodium because it wants to go from an area where there's a low solute concentration where there's an area where there's high solute concentration. So essentially it's the sodium that's making water reabsorption happen here at the proximal convoluted tubules. And we have these little aquaporins. Those are the water pores or water membrane transporters for water. So we have a pretty set number of them in the proximal convoluted tubule. So most of the time, the water, 65% of our water is going to be reabsorbed. So that stays pretty stable. It can vary a little bit, but stays pretty stable. The next area where you'll see water reabsorption is the descending limb of the loop of Henle. So we'll get some water reabsorption going on there, again through aquaporins. And we will, when the tubular fluid gets to the turn here of the loop and we start entering the ascending limb, realize that the ascending limb of the loop of Henle and the distal convoluted tubule, they do not allow water reabsorption. So they're impermeable to water. So we're not going to get any water reabsorption along here. So not along the ascending limb of the loop of Henle and the distal convoluted tubule. But when we get to the collecting tubule and the collecting duct, then we can get some more water reabsorption, and this is the area where it's regulated. So we got about 75% of water, average, getting reabsorbed early on here. And then how much gets reabsorbed here is regulated based on our body's needs. So based on our fluid intake and our fluid excretion, you know, how much water we need to reabsorb along here. So this picture down here is showing what's going on. All right, again, the regulators of water reabsorption along the collecting tubules and ducts is two hormones involved. The first one is aldosterone, and so I don't think I mentioned this before, but if we slide back up to aldosterone working with the sodium, so remember aldosterone would, if it was present, it would allow for the production of more sodium channels and sodium-potassium pumps. So you'll notice sodium will move, we'll get more sodium reabsorption. Remember, water is going to follow sodium because it wants to move from an area where there's a low solute concentration, so into an area where there's a higher solute concentration, so water will follow. So that's essentially, that hormone aldosterone is allowing for water reabsorption because it is allowing for more sodium reabsorption, and water will follow sodium. So that's one hormone that can influence water reabsorption, and that's aldosterone, and it does it kind of indirectly through increasing sodium reabsorption. And then the other hormone we've heard of too is the antidiuretic hormone, the abbreviated ADH. I'm done. Oh, no, I apologize. I can't see the little timer, and then I don't know what time it is, and I feel like so apologize for that little lull. All right, so we still have a few minutes. So the antidiuretic hormone is the hormone that is also going to help regulate water reabsorption along the distal convoluted tubules and collecting ducts. And how it does it, the antidiuretic hormone is going to cause an increase in the number of aquaporins that are present. So when we get in more aquaporins, there's more ways for water to move from the tubular fluid into the blood. So the water will flow in that direction. The reason the water will flow in that direction, again, is based on the solute concentration being higher in the interstitial fluid. So it'll want to move that way just because of that reason. And then the next thing we'll talk about is how the kidneys or nephrons are keeping the interstitial fluid with a higher solute concentration. So that water will move in that direction. So that's one thing that we have a concentration gradient set up so that water, if we put more aquaporins, antidiuretic hormone allows for the increase in aquaporins, water will want to move through them from the tubular fluid to the water. So that's the role that antidiuretic hormone has in regulating water reabsorption. All right, so the next video will talk about waste products, I believe.